Hello, this is Imatit with Samuel, okay? And in today's lesson, we are going to be solving this exponential equation, m raised to power n equals n raised to power m. The moment you see an exponential equation like this, probably the first thing that comes to your mind is n is equal to m, such that when n is equal to 1, m will be equal to 1, and when n is equal to 2, m is equal to 2, and so on and so forth. You probably are right. And you see that m and m cannot be equal to 0, and that's because 0 raised to power 0 is not equal to 1, right? Okay, so but you also notice that there should be other solution, like 2 raised to power 4 is equal to 4 raised to power 2, both of which are equal, right? Such that when m is equal to 2, n is equal to 4, and vice versa. All these are possible solutions. So, well, as a mathematicians, we have to be able to prove this mathematically, and that's what we're going to do in this lesson. So we're going to set an n is equal to a product of a constant c and m. Okay, so that's what we're going to do. So let us go on and replace n with cm here. So we have m raised to power cm equals cm in bracket and raised to power m. Okay. Next, I think we should get rid of the m on the power, right? We can do that by expressing both sides to the power of 1 all over m, right? Okay, let's do that. So when we do that, we would have m raised to power c, right? And that's equal to c multiplied by m, right? Okay, yeah, we're getting somewhere. Let us divide both sides by m. Okay, when we divide both sides by m, on the left hand side we have m raised to power c equal all over m, and that equals c. So applying the law of indices, this is the same as m raised to power c minus 1, right? And that's equal to c. Now I will try to put all the c on one side, and I can do that by expressing both sides to the power of 1 all over c minus 1. Let's do that. So we're going to have m on this side, right? So we'll have m on the left hand side, and that will be equal to c raised to power 1 and divided by c minus 1. I hope you agree with that. So we have m is equal to c raised to power 1 all over c minus 1. Okay, great. Now we've obtained the value of m. What of n? We set n is equal to cm originally. So let us take it from there. So n is equal to c multiplied by m. So and that's going to be equal to c multiplied by m is c raised to power 1 all over c minus 1. So applying law of indices there, the first c there is raised to power 1, so we add the power up. So 1 plus 1 all over c minus 1 would be c raised to power, down there we have c minus 1, and that will be c minus 1 and plus 1, right? So we are going to be having that's equal to c raised to power c all over c minus 1, right? And that is n. So let me put that down up here, so that we can use it for obtaining the results. So we have m is equal to c raised to power 1 all over c minus 1, and n is equal to c raised to power c over c minus 1. So we can try different value for c to obtain all the possible solution for m and n respectively. So we can try for when c is plus or minus 1, plus or minus 2, plus or minus 3, and so on and so forth. We won't bother trying 0, okay? Well, some or a lot of these might not apply. So even the negative, some of them might not apply. But let us go on and try c is equal to 2, okay? Positive 2. So in that case, m is going to be 2 raised to power 1 all over 2 minus 1, right? Which is going to be equal to 2. And n is going to be equal to 2 all over 2 minus 1. That's going to be 2 raised to power 2, which is 4. And you can see that is one of the solutions obtained there. You can go on testing for different value of c so that you can obtain all the possible solution for the exponential equation. So this is an interesting one. You can go on your own and test for all those results. But please hit the like button, and until next time, keep marking it and keep winning.